Hello friends, in last two video lecture we learned the basic for writing the electronic configuration. In first part we learn the quantum number, then in second part we learn about the above principle, Hund's rule and Pauli exclusion principle. Now in today's video lecture we are going to discuss about actually how to write the electronic configuration, that is part third. But first we can see here what is called as electronic configuration. Now electronic configuration means the arrangement of electron in orbit or in orbitals, means how you have to place the electron in orbit or in orbital. Then this arrangement is called as electronic configuration. And friends, electronic configuration is written in three ways. In first way, we can write orbit or cell electronic configuration. Just for example, 2, 8, 18, 32. These pattern for mentioning the electron is called as cell electronic configuration, or it is also called as orbit electronic configuration. Means you have to mention here the capacity of electron in cell, then it is cell electronic configuration. Then second type is orbital or complete electronic configuration, and this electronic configuration is written on the basis of above principle, and here you have to mention the electron capacity of orbital, just like 1s2, 2s2, 2p6, 3s2, 3p6. Now this is the orbital electronic configuration or complete electronic configuration of elements. Now then third pattern or third type, valence or last cell or outermost cell electronic configuration. Now in this configuration, first you can mention here the noble gas and then electron present in valence cell. Means first you can write here the noble gas and then valence cell electron in orbitals, and this is the third part, that is valence or last cell or outermost cell electronic configuration. Now in this way you have to write the electronic configuration in three types. First is cell electronic configuration, second is orbital or complete electronic configuration, and third is valence cell electronic configuration. Now before writing any types of electronic configuration, friends, you have to know the atomic number of all elements, because we know that atomic number will be equal to the number of electrons, and arrangement of electron will be called as the electronic configuration. So first term you have to remember, and this is atomic number of all elements. Now then second terms, you have to know here the capacity of electron in cell or in orbitals. If suppose you have to know here the capacity of K cell, then M cell, then N cell, then also capacity of S orbital, P orbital, D orbital, then you can easily write the electronic configuration. Now this is the second term you have to remember. Then third term, you have to remember the block, on which block the element is present. It is present in S block, it is present in P block, it is present in D block, or it is present in F block. Means you have to know here the block and all elements in periodic table. Now this is the third term you have to remember. Then fourth is you have to know here the group number and period number of all elements. On which group, on which period element is present. If suppose you have to remember it, then you can easily write the electronic configuration. Now then last one, you have to know the knowledge of quantum number, then above principle, Hund's rule and Pauli exclusion principle. Now if suppose you have to remember all the 5 points, then you can easily write the electronic configuration. First you have to know here the atomic number of all elements. Then secondly, capacity of cell or orbitals. Then third one become you have to know here the block and all elements in periodic table. Then fourth one is you have to know here the group number and period number of all elements, and also you have to know here the quantum number, above principle, Hund's rule and Pauli's exclusion principle. Then you can easily write the electronic configuration. Now friends, let us move towards the first type of electronic configuration, that is cell electronic configuration or orbital electronic configuration. So what is called as the cell electronic configuration? Now the arrangement of electron on the basis of capacity of cell or capacity of orbit, that is capacity of K cell, capacity of L cell, capacity of M cell, capacity of N cell, O cell, P cell and Q cell. Then the arrangement of electron on the basis of capacity of cell, then it is called as cell electronic configuration or orbit electronic configuration, and it is mentioned in the number, that is 2, 8, 18, 32. In this manner we can mention here the cell electronic configuration. Now for this you have to know here the capacity of cell and which orbitals are present in this cell. Now let us see here. First cell is the K cell, and K cell contains only one orbital, that is 1s orbital, and 1s orbital has 2 electron capacity. So K cell has 2 electron capacity. Then second one, L cell. L cell contains 2s and 2p orbitals, and s orbital has 2 electron capacity and p orbital has 6 electrons capacity. So total 8 electron is the capacity of L cell. Then M cell contains 3s, 3p and 3d, and the capacity of M cell is 18 electron, that is 2 plus 6 plus 10. Then fourth cell is N cell. N cell contains 4s, 4p, 4d and 4f orbitals, and the capacity of N cell is 32 electron. In this way O cell also has the capacity 32 electron, P cell also has the capacity 32 electron, then Q cell also has the capacity 32 electrons. And electrons are filled on the basis of capacity of cell, then it is called as cell electronic configuration. Now then how to write the cell electronic configuration? So here I have to distribute the cell electronic configuration in 4 parts. First we can write here the cell electronic configuration of S block element, then P block, then D block and then F block. So first we see here how to write the cell electronic configuration for S block element. Now for writing the cell electronic configuration of S block element, then you have to ignore or remove the 2 things. Means you have to remember here these two things, then you can easily write the cell electronic configuration of S block element. And which are these two things you have to ignore? Now first thing is you have to ignore n-1d orbital, and second thing is n-1f and n-2f orbitals. Now for writing the cell electronic configuration for S block element, you have to ignore the three types of orbitals, that is n-1 d orbital, n-1 f orbital and n-2 f orbitals. And here n means the period number or cell number or principal quantum number. And in this way, if suppose you have to remove these two things, then you can easily write the cell electronic configuration of S block element. Just for example, how to write the cell electronic configuration of potassium. Now here I can take the potassium. Now we know that potassium is present in S block. So here I can mention the block in which potassium is present, and potassium is present in S block. Then also I mention here the atomic number of potassium. If suppose you have to know here the atomic number, then you can easily fill up the electrons in orbit. So it is very, very important to remember the atomic element of any one elements. Now then third, the period number, and the period number of potassium is fourth. Means potassium is present in fourth period, means the value of n is equal to 4. Now here potassium is the S block, and for writing the cell electronic configuration you have to remember here the two things. First thing is you have to ignore here the n-1d orbital, then n-1 f orbital and n-2 f orbital. And then here the value of n is 4. So n-1d means 4 minus 1d, and 4 minus 1 means 3d. Means you have to ignore here the 3d orbital. Now then n-1 f and n-1 value of n is 4, means 4 minus 1 f means 3f, but 3f orbital is not present. F orbital will be start from the 4f, 4f, 5f, 6f. Remember here 3f orbital is not present, so there is no problem. Now then n-2f, here 4 minus 2f means 2f, and again here the 2f orbital is not present. Means here out of two things, n-1d means 3d orbital you have to ignore for writing the cell electronic configuration of potassium. Now then here I have to mention all cell, that is K cell is the first, then L, M and then N. K cell contains 1s orbital, L cell contains 2s and 2p, M cell contains 3s, 3p and 3d, but here 3d you have to ignore. Then N cell contains 4s, 4p, 4d and 4f orbital. Now then I have to fill here the electrons on the basis of capacity of orbitals. Now s orbital has 2 electrons capacity, so Here 2 electrons is present, means K cell contains 2 electrons. Then L cell. L cell contains 2s and 2p orbital. S orbital has 2 electron capacity, p orbital has 6 electron capacity. So total 8 electrons are present in L cell. Then M cell. M cell contains 3s, 3p and 3d. But 3d you have to ignore here. So S orbital has 2 electron, 3p orbital has 6 electron. So total electron in this cell is 8. Means 8 electrons is present in M cell. So here 2 plus 8, that is 10, plus 8, 18, and the atomic number of potassium is 19. So 1 electron is remaining and it is present in next cell, that is N cell, and N cell contains 4 s orbital and 1 electron present in s orbital. So total electrons are 2 plus 8 plus 8 plus 1, that is equal to 19, and 19 is the atomic number of potassium. So K cell contains 2 electron, then L cell contains 8 electron, M cell contains 8 electron, and N cell contains 1 electron. And if you have to mention the capacity of K cell, M cell, N cell, then cell electronic configuration of potassium is obtained, and the cell electronic configuration of potassium is 2, 8, 8, 1. In this way you can write the cell electronic configuration of potassium on the basis of two things. First thing is n-1 d orbital is ignored. Then second thing is n-1 f orbital and n-2 f orbital you have to ignore. Then you can easily write the cell electronic configuration. Then second example, how to write the cell electronic configuration of radium. Now first you have to know here radium is present in which block, then what is the atomic number of radium, and then what is the period number of radium. Now radium is present in second group, that is in S block. Then the atomic number of radium is 88. It is find out on the basis of 5 scale, 2, 8, 18, 18, 32. And then period number, and radium present in 7 period. Now here the value of n is 7, and we know that for writing the cell electronic configuration of S block element you have to ignore the two things, that is n-1 d orbital, then n-1 f orbital and n-2 f orbital. Now let us see here the value of period number is 7, that is the n equal to 7, and 7 minus 1 d means 6d, and 6d orbital you have to ignore. Then n-1 f means 7 minus 1 f means 6f, and 6f is again present in p cell, and it is also you have to ignore. Means 6d and 6f you have to ignore from p cell. Now then n-2f, 7 minus 2f means 5f, and 5f is present in O cell. So here also you have to ignore the 5f, and then you have to fill up the electron on the basis of orbitals. Then the capacity of K cell, M cell and N cell will be obtained. Now Let us see here for K cell. K cell contains 1s orbital and it has 2 electron capacity. Then N cell. L cell contains 2s 2p means total 8 electron capacity. Then M cell 3s 3p and 3d total 18 electron capacity. N cell contains 4s 4p 4d and 4f. So total 32 electron capacity for N cell. Then O cell. O cell contains 5s 5p 5d and 5f orbital. But here 5f orbital you have to ignore. Then total number of electron is 2, 6 and 10 means 18 electron is present in O cell. Then P cell. P cell contains 6s, 6p, 6d and 6f. Here 6d and 6f you have to ignore. So total electron capacity for P cell is 8. Then count the electron. 2 plus 8 plus 18 plus 32 plus 18 plus 8. Then it is 86 and 2 electrons are remaining and these 2 electrons is present in Q cell, that is in 7s orbital. So total electron is 88 and 88 is the atomic number of radium. So cell electronic configuration of radium is 2, 8, 18, 32, 18, 8 and 2. This is the cell electronic configuration of radium. In this way you can write the cell electronic configuration of every elements in S block, but you have to remember here the 2 things, and these 2 things are you have to ignore here the n-1 d orbital, then n-1 f orbital and n-2 f orbital. Then you can easily write the cell electronic configuration of every elements in S block. Now let us move to the cell electronic configuration of P block element. Now for P block element we have to remember here only one thing. You have to ignore the n-1 f orbital. Means for P block element you have to remember here the only one thing, and this thing is n-1 f orbital you have to ignore. Just for example here, how to write the cell electronic configuration of bromine. And friends, bromine is P block element. Then what is its atomic number? Its atomic number is 35 and bromine is present in 4th period. And for writing the cell electronic configuration of P block elements, you have to remember here only one thing, that is n-1 f orbital you have to ignore. And putting the value of n is equal to 4, then n-1 means 4 minus 1 f means 3f orbital you have to ignore. But actually 3f orbital is not present because f orbital is start from 4f. Now then how to write the cell electronic configuration of bromine? Now first cell contains 1s orbital, so it has only 2 electron capacity. Then L cell contains 2s and 2p orbital, so L cell has 8 electron capacity. Then M cell contains 3s 3p and 3d orbital, and so M cell has 18 electron capacity. Now here total electron is 2 plus 8 plus 18 means 28 and atomic number of bromine is 35. So total 7 electron is remaining and it is present in N cell. will contains 4s has 2 electrons, 4p has 5 electrons. So n cell contains the 7 electron. So the cell electronic configuration of bromine is first cell, that is contains 2 electrons, second cell contains 8 electron, then 18, and last one is 7. So cell electronic configuration of bromine is 2, 8, 18, 7. Now then second example, how to write the cell electronic configuration of lead, means Pb. Now lead is the p block element and it is present in carbon family, and the atomic number of lead is 82. Now then period number. Now lead is present in 6th period, and so the value of N is 6. Now we know that for p block element you have to ignore here the n-1 f orbital, and here the value of N is 6. So 6 minus 1 f means 5 f orbital you have to ignore. Now then you can write here the cell capacity. K cell contains 1s orbital and it has 2 electron capacity. Then L cell contains 2s 2p, so 8 electron capacity. M cell contains 3s 3p 3d, so 18 electron capacity. N cell contains 4s 4p 4d and 4f, so it has 32 electron capacity. Then O cell contains 5s 5p 5d and 5f, but here you have to ignore the 5f orbital. So the capacity of this cell, that is O cell, is 2, 6 and 10, means 18 electron. So total electrons are 2 plus 8 10 plus 18 28, then 32 plus 18, which is equal to 78. So 4 electrons are remaining, and these 4 electrons are present in P cell, and P cell contains 6s orbital which contains 2 electron, then 6p orbital will contains here the 2 electrons, so total electrons is 4. So P cell contains 4 electrons, and the cell electronic configuration of lead is 2, 8, 18, 32, 18 and 4. In this way we can write here the cell electronic configuration of p block elements. But for writing the cell electronic configuration for p block elements, you have to remember here the only one thing, and this thing is you have to ignore n-1 f orbital. And if suppose you have to remember it, then you can easily write the cell electronic configuration of p block element. Now then let's move to cell electronic configuration of d block element. And for writing the cell electronic configuration of d block element, you have to remember here the 3 things. And first thing is, first fill up the ns orbital, means firstly you have to fill up here the ns orbital. Now then fill up n-1 d orbital, and third is ignore n-1 f orbital. And if you remember these 3 things, then you can easily write the cell electronic configuration of d block element. So what is the first thing? Firstly you have to fill up the ns orbital, then you have to fill up n-1 d orbital and ignore n minus 1 f orbital. Now let us see here the example. How to write the electronic configuration of scandium. And scandium is the d block element, 3d series element, and the atomic number of scandium is 21, and it is present in 4th period. So value of n equal to 4. And for writing the cell electronic configuration of d block element, you have to remember here the 3 things. First thing is, first fill ns, and the value of n is 4. So first fill up the 4s orbital and then fill up n minus 1d, means 4 minus 1d means 3d orbital. Means firstly you can fill the 4s, then 3d, and ignore n minus 1f. n means 4, 4 minus 1f means 3f, but 3f is not present because f orbital is start from 4f. So here only 2 things will be applied for scandium, and first fill up the 4s orbital and then fill up the 3d orbital. Now let us see here the capacity of each cell. K cell contains 1s and 1s contains 2 electrons, so the capacity of K is 2. Then L, 2s, 2p means total 8 electron capacity. M cell contains 3s, 3p and 3d, and 3d you have to fill after the 4s. Remember here. So first we can fill up the 4s, and 4s is present in N cell. So here 4s contains 2 electrons, and then 3d you have to fill up with remaining electron. So here total electron is 2 plus 2 4 plus 6 10 plus 2 12 plus 6 18. Then 4s contains 2 means 20, and 1 electron is remaining, that is present in 3d orbital. Means first you can fill up here the 4s orbital and remaining electrons enters in d orbital, 3d orbitals. And this is the thing for d block element. Means first you can fill up here the ns and then n minus 1 d. And so the cell electronic configuration of scandium is: K cell contains 2 electron, L cell contains 8 electron, M cell contains total 2 plus 6 plus 1, total is 9, and N cell contains 2 electron. So its cell electronic configuration is 2 8 9 2. Now then second example for d block element, and how to write the cell electronic configuration of tungsten, that is W. Tungsten is d block element and it is present in 5d transition series, and its atomic number is 74, and it is present in 6th period, means the value of n is 6. And for d block element you have to remember here the 3 things. First you have to fill up here the ns orbital. Ns means here period number is 6, so 6s fill first, and then n minus 1d orbital, means 6 minus 1d means 5d orbital, and ignore n minus 1 f orbital, means 6 minus 1 f means 5f orbital, you have to ignore here. Means for writing the d block elements, first we can fill up here the ns, that is 6s, and then 5d, and 5f you have to ignore. Now let us see here for electron capacity of each cell. K cell contains 1s electron, so it has 2 electron capacity. L cell 8, M cell 3s, 3p and 3d, so 18 electron. N cell contains 4s, 4p, 4d and 4f, so total 32 electron capacity for N cell, then O cell, 5s, 5p, 5d and 5f, and here you have to ignore the 5f orbital. And then next cell is P cell. P cell contains 6s, 6p, 6d and 6f. So it has again 32 electron capacity, but the atomic number of tungsten is 74. So here K cell contains 2 electron, L cell contains 8, M 18, then N 32, then O cell. O cell contains 5d orbital and P cell contains 6s. So NS means 6s you have to fill up first, and 2 electron enters in 6s orbital. So total electron is 70. Then remaining 4 electron enters in 5d orbital. So total electron is 74. And the electron present in O cell is 2, 6, 4, means total 12 electron. And 2 electrons is present in P cell, that is in 6s. So the cell electronic configuration of tungsten is 2, 8, 18, 32, then 12 and 2. And in this way you can easily write the cell electronic configuration of D block element, but you have to remember here the 3 things. And first thing is you have to fill up first ns orbital, then fill up n-1 d orbital and ignore n-1 f orbital. And for a block element, how to write the cell electronic configuration of a block element? And for writing the cell electronic configuration for a block element, you have to remember here the 5 things. First thing is, first fill up the ns. Second thing is, then you have to fill up here n-1 s and n-1 p orbital, and then fill up n-1 d orbital with only 1 electron, means d orbital contains only 1 electron, and lastly fill up n-2 f orbital. And fifth thing is ignore n-1 f orbital. And if you have to remember all the 5 things, first thing is first fill up ns, then fill up n-1 s and n-1 p, then fill up n-1 d with only 1 electron, and lastly fill up the n-2 f orbital and ignore n-1 f orbital. And if suppose you have to remember these 5 things, you can easily write the cell electronic configuration of a block element. For example, how to write the cell electronic configuration of cerium? And cerium is lanthanide series element, so it is a block element and its atomic number is 58, 57 for lanthanum and 58 for cerium, and it is present in 6th period, means the value of n is 6. Now then, for writing the cell electronic configuration of a block element, you have to remember the 5 things. And first thing is first fill up ns, and the value of n is 6, so 6s orbital filled first. Now then n-1 s and n-1 p, and the value of n is 6, means 6 minus 1 means 5s and 5p, means first fill up 6s, then fill up 5s and 5p, and then fill up n minus 1d. N means 6, 6 minus 1 means 5d, and 5d contains only one electron you have to fill up, only one electron. And lastly, n minus 2f, 6 minus 2 means 4f, and ignore n minus 1f means 6 minus 1 means 5f, you have to ignore. So what is the first thing? First fill up 6s, then fill up 5s and 5p, then fill up 5d with only one electron, and lastly fill up n minus 2f, that is 4f orbital with remaining electron, and ignore the 5f orbital. So let us see here the capacity of cell. K cell contains 1s orbital, so it has 2 electron capacity. L contains 2s 2p, means total 8 electron capacity. M cell contains 3s 3p 3d, means total 18 electron capacity. Then N cell contains 4s 4p 4d and 4f. Now here 4f is present and it is fill up lastly. Now then O cell contains 5s 5p 5d 5f, and 5f you have to ignore, but 5d contains only one electron you have to fill up. Now then P cell contains 6s, and 6s you have to fill up first, and the capacity of 6s is 2 electron. So here you have to place 2 electron, then fill up 5s and 5p. 5s contains 2 electron, 5p contains 6 electron, and 5d contains only 1 electron. So total electron in O cell is 9, and in P cell will contains 2. Means here 2 plus 8 plus 18 plus 18 plus 9 plus 2 means 57, and 1 electron is remaining, and this electron is present in last cell, that is 4f. You have to fill up, and so it contains total 19 electron. 2 plus 6 plus 10 plus 1, total 19. And the cell electronic configuration of cerium is 2, 8, 18, 19, 9, 2. In this way, you can write the cell electronic configuration of a block element, but you have to remember here the 5 things. And first thing is, first you have to fill up the ns orbital, then you have to fill up n minus 1 s and p orbital, then fill up n minus 1 d orbital, and lastly fill up the n minus 2 f orbital, and ignore n minus 1 f orbital. In this way, if suppose you have to remember all these 5 things, then you can easily write the cell electronic configuration of a block element. In this way, you can remember the different things for S block element, P block element, D block element, and F block element. You can easily write the cell electronic configuration of every element in periodic table. So lastly, we conclude here, for writing the cell electronic configuration for S block element, you have to remember the 2 things, and it is related for the ignore of orbital. And first thing is n minus 1 d orbital you have to ignore, and second thing is n minus 1 f and n minus 2 f orbital is ignore. Now for P block element, you have to ignore here the n minus 1 f orbital, that is only one thing. And then for D block element, first fill up and then ignore. And for filling the orbital, there are two things. First is first fill up ns and then n-1 d, and ignore n-1 f orbital. And for f block element, there are total 5 things. 4 for filling of orbital and 1 for ignorance. Then first fill up ns, then fill up n-1 s and p orbital, then fill up n-1 d contains only 1 electron, and n-2 f orbital lastly, and ignore n-1 f orbital. And if suppose you have to remember all these things, then you can easily write the cell electronic configuration of S block element, P block element, D block element and F block element. So this is the cell electronic configuration. Now second part is orbital or complete electronic configuration, and third part or third type is valence cell electronic configuration or outermost cell electronic configuration. These two parts will be seen in next video lecture. Thank you.